Hello, everyone. Welcome to the platform of Let's Conquer It. So, today we're having a demo session on textiles. So, firstly, let me introduce you myself. My name is Prachi. I'm an educator at the platform of LCI. So, in today's session, I will teach you these four topics: manufacturing process of fiber to apparel, classification of fiber, difference between blended and mixed fiber, and molecular arrangement of fiber. So let's move further. This is the manufacturing process of fiber to apparel. Okay, so these are the different kinds of question we can see in the previous year, that there are different kinds of question which has been asked from the this process, this step, spinning steps. Okay, they can ask cotton spinning process, silk spinning process, and linen spinning process. So here I will tell you the short kind of processes which we can study in the depth in the regular classes. Okay, so this is the manufacturing process from the fiber till the making of the garment, means apparel. Okay, so first we have to source the fiber. Okay, that can be any kind of fiber, like natural as well as the synthetic one. Okay, so basically there are different kinds of fibers. Let that I will tell you in the next slide. So first we source the fiber. Okay, then we will do spinning process. So spinning is the process to make yarn from the fibers. Okay, so first we source the fibers, then we will make yarn by the spinning process, and then we will make fabric from the yarn by using knitting, weaving, and there is another method, that is non-woven technique. Okay, so there are mainly basically three kinds of techniques: knitting, weaving, or non-woven. So by these all techniques we can make fabric from the yarn. Okay, then we can perform different kinds of finishing processes like dyeing, printing, any extra kind of finishes, like if I want any specific purpose of fabric for a specific purpose, now then I will do any specific kind of finishing on that particular fabric. So I will do finishing on this fabric, then I will do cutting, sewing, stitching. There are different kinds of steps which we can perform to make apparel from that finished fabric. Okay, so this is the whole manufacturing process, how we will make yarn, then fabric, then finished fabric to the apparel. Okay, that will be the garment. So this is the whole process. So next, this is similar to the previous one, that this is also a manufacturing process which is used in textile industry. Okay, so basically from the sourcing of the fiber till the finishing. Okay, so till the finishing we can perform in the textile industry. So after the finishing fabric, they send to the manufacturing unit, to the garment manufacturing unit, and they will make different kinds of garments as per the need, as per the buyer requirement. Okay, so first, suppose for example, first we source cotton fiber. Okay, so as we all know, cotton is natural fiber and we can obtain it from plant. Okay, so cotton is a seed fiber. So first we will source fiber. Okay, then we will make yarn, then we will do weaving. We can perform weaving on the looms. Okay, so there are different kinds of looms on that, on which we can perform weaving process. Then we will do pre-treatment finishes. Okay, so I told you in the previous slide that we can do finishing on different kinds of fabric. So these are pre-treatment finishes, which is very important. If you are going to make any kind of garment, then you have to perform pre-treatment finishes. Okay, so there are different kinds of pre-treatment finishes. Suppose for example, sourcing, desizing, bleaching, mercerization. So their application is very different depending upon which kind of pre-treatment finishes do you want. Okay, then we can do, after pre-treatment finishes, we can do dyeing, printing, depending upon what kind of technique we want to use, or what kind of effect we want on those fabric. Then we will do finishing. So finishing, what is the difference between finishing and pre-treatment finishes? Pre-treatment finishes is done before the dyeing or printing. Okay, so this is the main process, important process to do dyeing or printing. Without pre-treatment finishes, we cannot perform good quality dyed fabric or printed fabric. Okay, so this finish is quite different from pre-treatment finishes. Let me tell you how. Suppose if I want any kind of waterproof fabric, okay, if I want that, I will gonna make the umbrella from that fabric or raincoat from that particular fabric, then what I will use, I will use waterproof finishes on that fabric. Okay, so there are different kinds of resins, different kinds of chemicals which we can use on waterproof finishes. Or I want to make antimicrobial finishes, I want to make anti pilling kind of fabric, then I will use finishing. Okay, so this is the finishing process. Still here, this we will perform all this in the textile industry. After this, we will perform in the garment manufacturing processes. Okay, so here they will make different kinds of garments. So this section will cover in the apparel design unit. Okay, so next let me tell you the classification of fibers. So there are basically two kinds of fibers: natural fibers and synthetic fibers. Okay, so synthetic fibers are also known as manufactured fibers. Okay, so in the natural fibers, again there is a classification on the basis of plant, on the basis of animal, and there is one more mineral fiber. Okay, so in the plant fiber, again there is a classification because there are some fibers which we can obtain from stem. There are some fibers which we can obtain from seed. Okay, same as there is again a classification again in the animal fibers. Okay, so we can obtained from wool, sheep, angora, like rabbit, mohair. So these are the classification again in the wool fiber. So this is very wide, and you have to learn. So this is very important topic. Okay, note down. This is very important topic. You cannot skip this topic because in the examination they can ask that what kind of fibers obtained in the plant category or animal category. And so let's talk about synthetic fibers. Okay, so there are some regenerated fibers and some synthetic fibers. So what is difference between regenerated and synthetic one? So regenerated fibers are those fibers which we can make through chemicals. We can use chemicals, but we we take the raw material is natural. Whatever the raw material is natural, but we can mix in the chemicals. So we can make regenerated fibers by using raw material, natural raw material, and by mixing through some chemicals we can make regenerated fibers. Okay, like in the viscose we use wood pulp. Okay, and there is synthetic fibers. So synthetic fibers are mainly derived from coal, from oil. So there are different kinds of synthetic fabrics like acrylic, nylon, polyester, lycra, and there are different aramid fibers and tactile, so microfibers. Okay, so these all are the fibers, and this is the classification of the fibers. So this is very important. Okay, let's move further. Okay, so I told you previously the classification of fibers like natural and the synthetic. Okay, but now I will tell you what is the difference between blended fiber and the mixed fiber. This is quite different from previous one. Like we have we have seen that there are different kinds of blended fibers now. So what is quite difference between blended or mixed fiber? So blended fiber is the combining of two or more than different fibers. Okay. So here we are mixing in the different kinds of fibers to make yarn. Okay. And usually combining a natural fibers with a synthetic fiber. So here we are mixing one natural or one synthetic. Okay. That can be their ratio can differ. Like if I'm mixing any kind of fiber like cotton, 20% cotton and 80% polyester. So their ratio can differ depending upon the properties you want, depending upon the purpose you want to use. But there will be one natural and one synthetic only. Okay. In the mixed fiber, what is the difference mainly? Here we are mixing two yarns. Okay. Here we are in the blends, we are mixing two kinds of fibers, but in the mixed In the mixed fiber, we are mixing two types of yarns. Okay, that can be knitted or that can be woven yarn. Okay, so these two are the technique by which we can make different kinds of fabrics. Okay, for example, like now the question comes in the mind, why fibers are blended, means what is the purpose behind the blending of the fibers. So we can improve the appearance, improve performance, improve comfort, and reduce cost. Okay, like if I want to use cotton fabric, okay, I want to use more ratio of cotton, like 80% of cotton, but I don't want that, because cotton is more absorbing now, that absorb more water. So I don't want to use that particular fabric is more absorbent. Then I will add what, 20% of polyester. Okay, so that can be the ratio depending upon the purpose what I want. Okay, that also improve performance, improve comfort, and reduce cost. So let's take the example of common fibers blended. So there are certain fibers which are commonly blended: polyester and cotton. Like I have already told you, I've already given the example. So if we are making polyester and cotton na, then we can do easy care, है ना, and we can also do crease resistance. We can also add the property of crease resistance, because polyester is not that absorbent fiber, but cotton is absorbent fiber. Then we can add polyester and cotton. Okay, next is cotton plus lycra. So how can we add cotton or lycra? Suppose we want jeans which should be comfortable, but at the same time there should be the stretching property also. Then because lycra is the stretching fiber now, that lycra is lycra can stretch its 5 times. Okay, so we will add cotton with lycra fiber. Okay, so by which we can make jeans more comfortable, more stretchy, fit better than cotton jeans. Okay, next is acrylic and wool blends. So this is very common blending fibers. Like we cannot use total pure wool, because wool is very costly. Okay, pure wool is very costly. So trousers will, whenever we will use pure wool na, those trousers will be very expensive. So for making less expensive, for imparting the property reduce cost, we will blend acrylic and the wool fiber. Okay, so I think this is clear to all of you. So next is molecular arrangement of fiber. So this is the molecular arrangement of the fiber. Like we have seen, a fiber is have their structure. Different fibers have their different kind of structures. Okay, but how they arranged, what kind of reasons they have, that I will tell you. So there is a molecular arrangement of the fiber. They have crystalline property and amorphous property. Okay, amorphous region and crystalline region. These both are present in all types of fibers, but again the ratio will differ. Okay, that can be 20% crystalline region or 75% crystalline region. That can be 80% amorphous or can 15% amorphous. That will depend on the property of the fiber. Okay, so let me tell you what is crystalline and what is amorphous. Okay, so crystallinity refers to the degree of structural order in a fiber molecule. Okay, so that defines the structure. How the structure will be of that particular fiber, that is depending upon the crystallinity. So crystal, in the crystal form na, the molecular chains arrange in regular manner. So they are very rigid and they arrange in a regular manner. Okay, but in amorphous region of the fiber is defined as the region of the fiber where there is no longer the order of the chain molecules. Okay, so these polymers are arranged in a very random manner. Like these are not rigid as compared to the crystalline. So crystalline region is very rigid, but amorphous arranged in a random manner. Okay, so they have more space, okay, in comparison of the crystalline region. So To make clear difference, let me tell you the basic difference between amorphous polymer and the crystalline polymer. Okay, so amorphous polymer are arranged randomly, like I have told you in the previous slide. Because they are arranged in this random manner, na, they are soft, they are quite soft. But arranged crystalline resin is very partial pattern, so they arrange in a rigid manner, so that's why they are hard. Okay, and amorphous resin do not have any uniformly packed molecules because they are arranging in a random manner. So in the exam na, they can ask properties of amorphous resin and crystalline resins, or they can take example of any of the fiber and they can ask ki which one have amorphous polymer more or which one have crystalline polymers. Okay, so amorphous resin have do not have sharp melting point. So what is the meaning of sharp melting point? Whenever we provide fume, whenever we provide burning uh, rate now to any kind of fiber, that is melt at certain time. Okay, but whenever any kind of fiber is having amorphous polymer, they do not have sharp melting point, means they melt very fast. Okay, and if any kind of fiber that have more crystalline resin, they have a sharp melting point. Okay, they will not sharp very fast, they will take certain time, then they will melt. Okay, so basically this is the difference. So amorphous polymers are transparent, but crystalline resin is opaque and translucent. Okay, amorphous resin is low, have a low shrinkage, but crystalline resin is high shrinkage. So amorphous is poor chemical resistance and crystalline is good chemical resistance. So whenever we talk about chemical resistance is a property of the fabric. If we uh, act any kind of fabric to any kind of chemical, like that can be acid or that can be alkali. Okay, so if we gonna test any kind of fabric with any acid or alkali na, that is damaged very fast in the amorphous property. But if the fiber is having crystalline resin more, that will be good chemical resistance. Okay, so in the amorphous polymer, lower strength due to poor orientation of molecules. Okay, because they are arranged in a random manner, na, that's why they are having lower strength. Okay, they are very very you can say break at certain period, but they have high strength due to better orientation because they arrange in a rigid manner, partial manner. Okay, so next is amorphous polymer have good water absorption. Okay, because they are arranged in a random manner, na, that's why they are having good water absorption power. But at the same time, crystalline polymers do not have good absorption power, so they have poor water penetration properties. And amorphous resin gives flexibility to fibers, but it gives strength to the fibers. So this is the main difference between amorphous and the crystalline polymer. Okay, so in this particular topic, this is very important topic again, and they can ask any kind of question, like they can ask directly the properties of amorphous resin or the properties of crystalline resins. Okay, so next is there are certain different kinds of fibers. Okay, so they have different kinds of amorphous resin and crystalline resins. Like I told you, na, their ratio can differ. So cotton have 30 to 35% amorphous resin and 60 to 70% of crystalline resin. Again, the flex is quite similar to the cotton fiber, so that's why they have similar kind of amorphous and crystalline property reasons. Viscose have 60 to 65% amorphous resin and 30 to 40% crystalline resins. Acetate is synthetic fiber. Okay, this have 60% of amorphous resin and 40% of crystalline resin. Wool is having 70 to 75% amorphous resin and 20 to 30% of crystalline regions. So these are different kinds of fibers. They have different ratios. You can see now how the difference between amorphous and the crystalline regions, because they have quite similar kind of structure, different kinds of structures. They have different kinds of properties. So these properties will depend on the polymer system, means amorphous or crystalline polymers. Okay, so I hope this is clear to all. So let's have some questions also. Like I have told you now, they can be asked any kind of questions like classification of the fibers. So this is the question. So if you are watching the session, then you can answer. Okay. So these are the different kinds of fibers, and these are the sources of the fibers. Okay. Let's see how many of you will do correct answer. You can choose A, B, C, D. Okay. Okay. So the correct answer is A. Yes, Sonal. Okay, you are right. So the correct answer is A. Cotton is obtained from seed hair. Pineapple is from plant leaf, flax plant stem, and coir is from fruit husk. So these are different categories from which we can obtain different kinds of fibers. Okay, so this is also a previous year question. Okay, so like this, these questions you can see in the examination. Okay, so next question is from amorphous and crystalline regions. Okay, yes, this is from amorphous region. So in the question, they asked higher percentage of amorphous resin exhibits the following properties in a fiber. Means if any kind of fiber having higher percentage of amorphous resin. So what are the properties they will have? Like I also told you na, the properties of amorphous resin. So what are the properties they will have? Yes, the correct answer is D. Okay, so like I already told you that those fibers who are having higher percentage of amorphous resins, they have lower chemical resistance. Okay, more absorbent and lower interpolymer force of attraction, because they are arranged in a random manner. Okay, they do not arranged in a rigid manner, so that's why they are having low interpolymer force of attraction and more absorbent. Like the very good example is cotton, and lower chemical resistance. They do not have stiff handle and strong internal bonds will be the property under in the crystalline regions. Okay, so I think these topics are clear to everyone. So if any student have any doubt, any kind of query, they can ask. So those topics which I already covered in this session, if you have any kind of doubts, you can ask. Okay, I think nobody have queries. Okay, thank you everyone. So let's end the session. Okay, thank you.